In the chemical reactions lab, we do not have like one big calculation that we're doing. So you're learning a lot of properties and identifying different substances or reaction types and so forth. So let me go over some of the basics that you need to know before we answer some of these questions. First, you need to be able to identify the general types of chemical reactions if you're given the equation. In other words, be able to recognize that if you have a substance doing a reaction like this, that's a decomposition. So the four you need to know are decomposition, combination, double replacement, and single replacement. Do look in the lab manual at the ones we did and kind of be familiar with them. You won't have to write them, but you'll have to be familiar with them and the types of observations that we had. Indications of a chemical reaction. You learned these before in the qual-quant lab, but change in color, if a precipitate forms, a change in mass, and if gas is produced, like bubbles. Okay. You also need to know the trend of group 2 cation solubility. So if you look on the periodic table, you'll see that this is the order from magnesium, calcium, strontium, and barium. And we're considering the cations, so I'm going to put charges on these. They're all +2. Okay, so the trend is that if you consider looking down, as you move down on the periodic table, those cations will form more precipitates. In other words, they will have more insoluble, water insoluble compounds. What I mean by more is, the solubility also depends on what anion the cation is with, what negative ion it's with. But odds are, with a given anion, the barium is going to be more likely to be insoluble. So the opposite is true as well. As you move up on the periodic table, you're going to have fewer precipitates. And this is a trend that we should have seen on that spot plate that we did, and we were looking at all the different white precipitates that formed. Okay. Another trend that you need to know is that there are 6 ions that only form water-soluble compounds. So these are never precipitates, or they're never involved in a precipitate. So it's the group 1 metals, the common ones here, and then nitrate, acetate, and ammonium. So those will never be in the precipitate. Okay, so that's some basic stuff. Let's go over here and answer these questions. So which one is more likely to be water soluble? I'm not telling you what X is, but it is going to be the negative ion. And what I just told you is that as you move down, they're less likely to be water soluble. This would be more likely to be a precipitate. So the magnesium X, whatever it is more likely to be water soluble. On this one, you should be able to recognize what kind of reaction this is. 2 ionic compounds, it's double replacement. You need to be able to predict the products on a double replacement. These are the ones we did on the spot plate. And to predict the products, you need to first know the charges of the different ions, so using the periodic table or what you have memorized. And then what you do is the front part of one goes with the back part of the other, so the calcium goes with the carbonate, and the sodium goes with the nitrate. And when I bring these over here, I have to consider the charges again and make sure that I have good formulas, and if each compound is neutral, and those are good formulas. I want to point out something real quick. You notice that I did not keep this 2, and the reason that I didn't is because this 2 was there because of that 2, because of the charge. That's why I needed it. I don't have a 2 here, so I don't need 2 sodium ions for that one. Okay, but I did keep this 3. And the reason that I kept that 3 is because that 3 is part of the polyatomic ion carbonate. So keep your polyatomic ions intact in these double replacement reactions. What else can I do? Well, I could balance this. Let's go ahead and do that before I forget. So 2 sodium, 2 sodium, 2 nitrate, 2 nitrate, 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. Okay, and then what else might I do? Well, I'm supposed to include the states. And so I need to say aqueous or solid. Well, this reaction does occur. That means one of these ionic compounds has to be a precipitate, a solid. And I know that it's not this sodium compound because I reviewed a minute ago that both sodium and nitrate can only form water-soluble compounds. So that means that my calcium carbonate must be my precipitate.